Ever since the beginning of the space age, some people have envisioned landing human beings on Mars. And there are a few who've taken things a step further. They envision not just landing on Mars, but having a population of humans who live there permanently. But how realistic is that dream? Could we actually do this? And if we can't, what would we need to do? Learn more about building a colony on Mars and what it would take on this episode of Everything Everywhere Daily. This episode is sponsored by ButcherBox. You've probably heard me talk about how ButcherBox only sells 100% grass-fed, grass-finished beef. But what exactly is that, and why does it matter? This type of beef comes from cattle that have grazed on grass for their entire lives, as opposed to being finished on a diet of grains and other feed at a feedlot. Basically, cattle eat what cattle are designed to eat. Grass-fed beef tends to have higher levels of omega-3 fatty acids, and grass-fed beef often contains more antioxidants, such as vitamin E. Beyond personal health benefits, choosing grass-fed, grass-finished beef can also improve soil health through natural fertilization and aeration, and can also promote greater biodiversity on grazing lands. Consuming grass-fed, grass-finished beef not only contributes to better health, but also supports more sustainable farming practices. Sign up at butcherbox.com/daily and get a special deal. New users who sign up for ButcherBox will receive 2 pounds of grass-fed ground beef in every box for the lifetime of their subscription, plus $20 off your first box when you use code DAILY at checkout. This episode is sponsored by MasterClass. If you're listening to this podcast, then you are someone who is curious about the world and loves to learn. And if you want to give the gift of learning and knowledge this Christmas, you can't do better than MasterClass. MasterClass offers online classes from some of the most successful instructors in the world in their fields. You can learn cooking from Gordon Ramsay, conservation from Dr. Jane Goodall, disruptive entrepreneurship from Sir Richard Branson, mathematical thinking from Fields Medal winner Terence Tao, and diplomacy from former Secretaries of State Madeleine Albright and Condoleezza Rice. You can access over 200 classes across 11 different categories. MasterClass always has great offers during the holidays, sometimes up to as much as 50% off. Head over to masterclass.com/everywhere for the current offer. That's up to 50% off at masterclass.com/everywhere. Once again, that's masterclass.com/everywhere. In a previous episode, I discussed what would be required to terraform Mars. This episode is not about that. Terraforming an entire planet would take hundreds, if not thousands of years, and an unspeakable amount of money. In this episode, I want to focus on the near term, or a time period much less than centuries. Something that could possibly happen within our lifetimes. So first, let's cover the relatively simple case of what would be required for the very first humans to just visit Mars. I say relatively simple because if and when humans finally set foot on Mars, it will be an incredibly difficult undertaking. However, compared to setting up a colony, it'll be relatively straightforward. First, let's compare what going to Mars would entail compared to what was required to go to the moon. The Apollo missions were much simpler compared to what would be required to get to Mars. The moon is relatively close, with an average distance of 238,855 miles, or 384,400 kilometers. Given its astronomically close distance, the craft used by the Apollo astronauts only had to provide enough life support for under 2 weeks. The longest Apollo mission was Apollo 17, which lasted just 12 days. Most people could suffer through living in a cramped space capsule for 12 days, so the accommodations didn't have to be comfortable or spacious. The food didn't have to be good, or even, for that matter, nutritious, because it was only 12 days. The moon has only 1/6 the gravity of Earth, so the lunar module didn't have to be very big, and half of it could be left on the surface of the moon. I don't want to take away from the incredible feat which was the Apollo program, but compared to going to Mars, it was a relative cakewalk. Over the last 50 years since the end of the Apollo program, space science has advanced, but we've been relatively limited in where we've gone. The fact is, since Apollo 17, there hasn't been a single space flight that has left low Earth orbit. The furthest any mission has gone was the recent Polaris Dawn mission by SpaceX, which took its crew of 1,400 kilometers or 870 miles from the surface of the Earth, which is still considered low Earth orbit. We now have a lot of experience in long-duration space flights. Many astronauts have spent months or even over a year on the International Space Station. It turns out that spending extended time in zero gravity isn't really great for human health. Without gravity, bones lose density at an accelerated rate, and muscles, especially in the lower body and back, atrophy from disuse. The cardiovascular system is affected as blood and fluids redistribute towards the upper body, potentially causing facial swelling, pressure on the eyes, and vision problems, something called spaceflight-associated neuroocular syndrome, or SANS. The heart also weakens over time as it no longer needs to pump as hard against gravity. Additionally, prolonged exposure to microgravity can impair immune function, alter gene expression, and disrupt the vestibular system, leading to balance and coordination issues. The longest single spaceflight was 438 consecutive days, set by Russian cosmonaut Valery Polyakov. This is important because a mission to Mars will take between 6 to 9 months. The closest distance between the Earth and Mars is 34.8 million miles or 56 million kilometers. The Earth and Mars have completely different orbits, so the only way to get there in a reasonable amount of time is to launch and return during a window that occurs only every 26 months. So, assuming our first trip to Mars will be a glorified Apollo mission where we go to land, plant a flag in the ground, pick up some rocks, and leave, it can be done within a time frame that we've already accomplished on the International Space Station. You would need a bigger ship for more supplies, and you would need a bigger landing craft due to Mars's increased gravity compared to the Moon. You might even need to send a supply ship to Mars before the crew arrives so that they have supplies available when they get there. The one thing we really don't have experience with for a short Mars mission is the long-term exposure to radiation in space. In low Earth orbit, astronauts are still protected by the Earth's magnetic field. In interplanetary space, you're constantly bombarded by cosmic rays and the solar wind. More on that in a bit. What would go into a single mission to Mars isn't that far beyond our technical knowledge today. That isn't to say it wouldn't be difficult and expensive, but it isn't that big of a stretch compared to what we've already done. Now let's assume that a mission to Mars is successful and we want to return. But this time, we want to create a permanent presence on the planet. Doing this isn't simply a matter of doing multiple missions like the first one to Mars. You need to develop an entire infrastructure to support the base. One of the first things you would need is a base on the Moon. The reason why you would want a base on the Moon has to do with gravity. The Moon has resources such as water ice, which can be converted into oxygen and hydrogen for rocket fuel. A lunar base could serve as a fuel depot, reducing the need to launch all the fuel from Earth. The Moon's lower gravity makes it much cheaper to launch spacecraft from the Moon than the Earth. Rockets could be refueled on the Moon and then launched more efficiently towards Mars. You could probably bypass a lunar base, at least initially, but in the long term it would make supporting a colony on Mars much easier. The next technology you would want to develop is nuclear rockets. Nuclear rockets require less fuel and can provide much more thrust compared to chemical rockets. These would be used in space to go between the Moon and Mars much more quickly. If you didn't have a nuclear rocket, you would have to wait every 2 years for any resupply or crew relief missions. A nuclear rocket could, in theory, travel between the Moon and Mars at any time, even though the trip would be longer when the Earth and Mars are on the opposite sides of the Sun. We have never fired a nuclear-powered rocket in space before, so this would be brand new technology, and I'll refer you to my previous episode on the subject. Consumables such as food, water, and oxygen will need to be created on the surface of Mars. Shipping these consumables, especially oxygen and water, all the way from Earth would become prohibitively expensive over time. We know Mars has water as well as carbon dioxide. These would need to be extracted and processed, which has never been done outside the Earth. The extraction of water and oxygen would need to be the top priority of the Mars colony, at least at first. Food would need to be grown on Mars. This is probably one of the lesser challenges, as we have lots of experience growing food in artificial environments, but there might be unexpected problems that would be encountered on Mars that we can't foresee. Another major problem would be radiation. Mars doesn't have a magnetic field, so harmful cosmic rays and solar winds would constantly bombard the colony. Most planning assumes that, in the long run, anyone living on Mars would have to live underground, or at least in a shelter covered by Martian soil. Long-term exposure to space radiation is another thing that we have never had to deal with before. One thing that people living on Mars wouldn't have to worry about is high winds. In the movie The Martian starring Matt Damon, the Mars base was threatened by a storm with high winds. High-speed winds can exist on Mars, but the air pressure is so low, less than 1% of that of the Earth, that it can't exert much force even at high speeds. Another problem that will be faced is energy. Solar panels can work on the surface of Mars. It's been used on many different rovers. However, they're not as efficient as those on Earth. On Earth, solar panels can receive, on average, about 1,000 watts per square meter at noon under clear skies. Mars is about 1.5 times further from the Sun than the Earth, receiving only about 43% of the Earth's solar energy. Dust storms can cover solar panels, but they could be cleaned if there was a crew there. It would mean doubling the number of solar panels to power a Mars base, or necessitating a small-scale nuclear power station as a long-term solution. Another big unknown is gravity. We have plenty of experience in zero gravity, and we know that extended time in zero gravity can be harmful. What we don't know is how humans will thrive in partial gravity. Do humans need the full gravity of Earth to thrive, or is at least partial gravity enough to avoid bone loss and muscle decay? The gravity on Mars is only 38% of that of the Earth. And this is something we'll probably never be able to test until humans actually spend time on Mars. Assuming we can solve the food, water, oxygen, radiation, and energy problems, there is still another issue: communications. At closest approach, radio signals take approximately 3 minutes one way between the Earth and Mars. But at their furthest distance, signals take about 22 minutes. This creates a round-trip delay of between 6 to 44 minutes. The high latency between the Earth and Mars cannot be overcome because of the speed of light. When the Earth and Mars are on the exact opposite sides of the Sun, communication is literally impossible. Currently, the rovers and orbiters around Mars communicate with Earth, but the time delay isn't that big of a problem because the rovers and orbiters are designed to behave very slowly. Moreover, the data transfer rate is quite low. Currently, Martian rovers communicate with Martian orbiters at a rate of about 1 to 2 megabits per second. There are limited windows when a satellite is overhead when data can be sent. The data speeds from the Martian satellites to Earth can vary depending on the orbiter, but they're all very slow. They're usually around the speeds of a dial-up modem. They can send images and data because they're sending it continuously, and because the folks at NASA have a lot of patience. This level of bandwidth isn't going to cut it for a Mars colony. There would be need for high-speed data that could send high-definition voice and video. NASA is currently working on a solution to the problem with a project known as the Deep Space Optical Communication System. The system uses lasers in the near-infrared region instead of radio waves. In 2023, this technology was tested on the Psyche mission, which is visiting the asteroid of the same name. Tests have shown that it can send data at rates between 25 to 267 megabits per second, depending on the distance. There is hope that future bandwidth speeds in space could reach as much as 10 gigabits per second. NASA's delay-tolerant networking protocol is designed for high-latency data environments. It's been tested on the International Space Station and is expected to play a key role in future Mars missions and other interplanetary communications. What I've listed in this episode are only some of the known issues that will have to be faced if we wish to have a permanent presence on Mars. there are probably a host of unknown issues that we can't even think of that will have to be addressed if this is ever actually attempted. But if at some point all of these issues can be overcome, it will be one of the biggest advancements in all of human history. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Kieffer. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere Daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.